the example of a metal, of a pure metal. This is, if you see, the pressure, temperature, equilibrium phase diagram for pure iron. Pure iron. We again have temperature in Celsius and pressure in atmospheres now, 1 atmosphere, 2 atmospheres. It is just that in the previous diagram, this vertical was pressure, horizontal was temperature. Here we have switched it so that temperature goes here, but it is still a temperature pressure phase diagram. The temperature varies 500, 1015, 2000 and so on. The pressure varies from 1 atmosphere, less than 1 atmosphere, higher than 1 atmosphere. And of course, if we increase the temperature to a very high temperature of 3000, 4000, something like that, even vapor will be there, gas, right? But normally, if you can just make liquid, then it is enough for metals. So at a high temperature of 2000 degrees or so, iron will become liquid. When you reduce the temperature and go to 1538, iron will become a solid. But there will be a solid which is called delta solid. If you reduce further at 1394, iron will change into another solid which is called gamma solid. If you change further at 910 degrees, iron will change into a third solid called alpha solid. And then alpha solid will remain. You keep on reducing the temperature until you reach 20, 25 degrees, which is the room temperature, or even 0. This will be there. So you see, if you have a very high temperature of 3000, 4000 degrees, iron will have melted into a liquid and then into a gas. Now, gas or vapor will be one phase, liquid will be one phase, and solid will be generally one phase. But here the solid will be delta solid, gamma solid, alpha solid. So iron is a unique material. We have already told you about polymorphism in a previous chapter, which is known as allotropy, if you remember in basic chemistry, which means that there is the same material, but it exists in different structures or morphologies. We gave you the example of carbon, which you know from before, that carbon is one material, but it can exist as graphite, which is there in the lead of your pencil, and it can exist as diamond, which is a precious stone. And both are carbon, but totally different structures and properties. So iron here has delta, gamma, and alpha, three phases. Now we have told you that alpha is a BCC phase, body-centered cubic, and gamma is a face-centered FCC, and delta is another type of BCC. It is also body-centered cubic, but with a different size of the crystal, right? And the temperatures are here. The temperatures are here. Now here in this diagram, there are 1, 2, and 3 triple points, because there are three phases, right? In water, there was only one solid phase. Therefore, there was one triple point. Here, there is this triple point because it touches the vapor state, the liquid state, and the delta solid state, delta solid. This triple point, vapor, delta solid, gamma solid. And this triple point, vapor, gamma solid, and alpha solid, right? So there are three triple points in this phase diagram, which is the phase diagram of one pure metal. And as an example, we have taken here iron, which is one of the rarest materials, which has three solid phases. When we were talking about general applications of material science and engineering, we told you that if we single out one material in the whole world which has the largest number of engineering applications, then it is iron and steel. And it has been there for thousands of years and is still today the largest number of engineering applications is iron, and it is because of this that it has three phases: delta, gamma, alpha. Each phase, as we have already told you, has a different structure, therefore it has a different property. So we can play with the properties of iron much more than we can play with the properties of other materials because of three solid phases coexisting, and that is why we can create steels of hundreds or thousands of different types with different properties and different structures. Let us move on now. Now we will talk of equilibrium of the phases and solubility limit, right? Equilibrium and solubility limit. If we talk of solubility, we will talk of solutions and mixtures, that. So what is a solution? You see, we take water, for example, and we take sugar. These are two different materials. But if you put some sugar inside water and keep on stirring it, after some time, you will see that the sugar and water become a uniform liquid, right? And that is now a mixture. So that liquid, which you see, it is a clear liquid. You cannot see where there was water and where there was sugar. It has completely dissolved into it. And now it is a mixture of water and sugar, and this type of a mixture is called a solution. If you try to add more sugar, you stir it more, it will also dissolve. But after a certain time, if you add any more sugar and you keep on stirring it, but it does not dissolve, and you can now see the liquid and you can see particles of sugar floating around. And if you don't stir too much now, then those particles will settle down at the bottom and you will call it a precipitate. So there will be a solubility limit, right? A solubility limit that you can dissolve only so much of a solid into a liquid, and after that it will not dissolve. So this is the solubility limit. Now here, if you see, this is the temperature, and here is the composition, weight percent of sugar in water, right? You understand, right, that when we have a solution where a solid has been dissolved, then 20% has dissolved, 30% has dissolved, 40% has dissolved, and so on, right? But this will change with temperature. If you are around 20 degrees, which is roughly the room temperature, right, then a certain amount of sugar can be dissolved. But if we increase the temperature to say 50 degrees, what do you think will happen? Can we dissolve more sugar or less? What do you think? You see, when you increase the temperature, the water molecules will start moving. The distance between them will increase, right? Water will expand. So there will be more gaps between the molecules of water. Therefore, when you add sugar molecules to it and the temperature is higher, then there are more gaps, so more sugar can dissolve into it. So let us see here if the same thing happens, right? Let us see here if the same thing happens. What is the solubility limit at 20 Celsius roughly? So we draw a horizontal line near the 20 degrees temperature, right? It is approximate here. I mean, it should be here, but say it is 20, right? So we draw a horizontal line and we cut this diagram and we say, oh, it is roughly 65%. So this is our answer, that around 20 degrees Celsius, if this is the solubility diagram, and we cut it, then about 65% water will dissolve. But if we go to say 60 degrees, then we draw a horizontal line here, the solubility will be higher, say 70%, right? So we have confirmed, right? So the answer is that around 20 degrees Celsius, the solubility of water is 65 weight percent sugar. So if you are less than 65 weight percent sugar, right? If the concentration is less than 55 weight percent sugar, then we will have completely liquid phase, right? Right? Because the solubility limit is 65. So if we have dissolved only 40% sugar, then it will be a clear liquid. But if you have dissolved more than 65, if you have dissolved say 80, then there will be liquid and there will be solid particles of sugar, right? We can see that. So therefore, this is the answer. So right, so this is solubility, and again we have now taken a material which is not a pure material. There are two materials, right? Water and sugar here. So when we have a solution or a mixture, then we are talking about solubility limit. Let us move.
Let's break some tradition. We take a break not at the beginning of one portion of the lecture, but at the end of this portion. So I hope I'm not repeating it. I think some time back we did a language joke. Let me do a different type of language joke today. These are normal times now, not COVID and so on. You are in a hi-fi coffee shop, in a special type of place and so on. And you are sitting there at a table taking some coffee, and you are young and your heart is young. A very smart girl enters the coffee shop. Now you don't want to look at her because it will be bad, but you want to. Now she comes, she walks, and you try not to look at her, but then she stops next to your table. Now your heart is, wow, she has stopped here. So you look up and there is a beautiful, smart girl. And then she asks you, are you single? Oh my goodness, you are so very happy. Oh, she is asking me if I am single. It means she wants to go out with me, this, that. He said, yes, of course. She said, okay, thank you. Takes a chair and goes to the other table. She just wanted to ask if you are alone, so I can take a chair, please. But English language problem, she said, are you single? And made you so very happy for some time. Break over.